Alright, so this is part 4 of this chapter. In this part, we talk about the intersection between circles and lines. Of course, we talk about how to interact their equations, right? So in order to find the intersection points. Now, there are 3 examples in this section. Now, first of all, the first one, we have a circle x squared and y squared, and 2x minus 3y minus 10 equals to 0. Now, usually it would be easier if the circle is in the general form, and the straight line will be x minus y plus 5 equals to 0, right? So we have a straight line, we have a circle. It's not necessary to draw a diagram because we are going to deal with the equations anyway. Alright, so to do that, actually, because they're both x and y in the equation, we will first use the method of substitution so as to remove one of the variable. Alright, so that only x or y remains. It's up to you. Choose x or choose xy. Choose x or to choose y. For example, in this case, I would first change it into x equals to y minus 5, and then I will do the substitution. I would replace all the x's into this circle equation, so that I have y minus 5 all square and y square and 2x, x becomes y minus 5. Alright, minus 3y minus 10 equals 0. Usually it becomes a quadratic equation in x or in y. In this case, it is in y. So that will give you 2y square minus, let me switch to black color, right? 2y square minus 11y and 5 equals to 0. You may pause the video and take some time to do the simplification on your own. Alright. In making this video, I skip in order to save time, I skip some of the steps. Right. Actually, I suggest you to do so. You pause the video and try to do it on your own. Alright. So after factorization, it gives me this. So there are y is 1 over 2 or y is 5. Alright. Once you have the value of y, you can use this orange equation to get the x as well. When y is 1 over 2, x will be minus 9 over 2. Or when y is 5, x will be 0. Alright. So that we have the intersection points. There are 2 intersection points. Alright. The intersections are minus 9 over 2, 1 over 2. This is one point. Or another point is 0, 5. This is another point. Alright. So we know between the circle and the straight line, there are 2 intersection points in this case. Alright. So if the quadratic equation here, this one, does not give you any solution, that means the 2 circles, there are no intersection points. If there is only one root, that means there is only one intersection point. When there is only one intersection point, we know that the straight line is tangent to the circle. Also, we know that it is only a quadratic equation, this one pointing in red, alright? This is only a quadratic equation, so it cannot give you 3 roots. It's also from the diagram. Given a circle in a straight line, you can never have the straight line cut the circle in 3 points. It is either 0, 1, or maybe 2, alright? Maybe 1, maybe 0. You can never have the same straight line cut the circle in 3 points because this quadratic equation can only give you at most 2 roots. Okay, so that's first example. Now let's look at another example. Say we have another circle x squared and y squared minus 2x and 3y minus 1 equals to 0. And then the straight line is x minus 2y plus 1 equals to 0. Alright. So once again, we look at this. We look at say I'll save the time. I will change this to x equals to 2y minus 1. Alright. And putting it into the original circle. Alright. And then that will give you, alright, you can do it on your own. Alright. That will give you 5y squared minus 5y plus 2 equals to 0. Alright, 5y squared minus 5y and 2 equals to 0. From here, we see that the discriminant is b squared minus 4ac minus 4 times 5 times 2, and that is smaller than 0. If the delta is not smaller than 0, that means there's no solution. No solution means that the circle and the straight line has no intersection. Alright, we can summarize it into three different configurations: the circle and the straight line. Alright, there might be no solution like this, there might be one solution like this, or maybe there are two solutions like this, which respectively corresponds to delta negative, 0, or positive delta. And that delta, mind you, is not the delta of the original circle. Alright, that is the delta when you group the circle and the straight line together. Alright, it's not the delta from the original circle. It is the delta when you put both of them together. It's the delta for this one. Alright, the discriminant for this equation. Alright. Another way to investigate the relation, how many intersection points between the circle and the straight line. Now, this way is investigating on the discriminant. Another is a geometry approach, right? Say, suppose you got a circle and then you got a straight line, all right? We want to study whether the straight line is outside, just cut the circle, or inside the circle. We can investigate the distance from the center to the straight line, this red distance. If the red distance, d, we want to compare it to the radius, alright? If d is greater than the radius, we have no intersection. If the distance equal to the radius, we have one intersection. If the distance is smaller than the radius, we have two intersection points. Alright, this is an alternative method. It's a geometry method to determine whether the straight line cuts the circle at 2, 1, or no intersection points. Alright, first is by delta. Second is by comparing the distance of the straight line from with the radius. Alright. Alright, now this is the second example, right? The third example is like that. It's a more open, open-ended question. We have x squared and y squared and 8x and 2y and 12 equals to 0. Alright, so this is one circle. And then we have a straight line, x and 2y, and k equals to 0. Oh, unfortunately, there is an unknown constant k in here. Alright, I don't know what k is. But I do know that there are two intersection points. The circle and the straight line intersect at 2 points. There are two intersections. Okay, so the question is, what is the values of k? Alright, find the range of values of k. What are the possible values of k so that there are two intersection points between the straight line and the circle? Alright, so we just do the similar thing, right? We replace, substitute the x or substitute the y, right? So in this case, I will put x is minus 2y minus k, so that we arrive at this particular substitution. We have minus 2y minus k square and y square, and 8 times minus 2y minus k and 2y and 12 equals to 0. You just substitute the orange equation into the x. Alright, and after some step, it becomes, now it's quite complicated in terms of the algebra, but I hope you can get the idea behind it. 4k minus 14 y and 12 minus 8x and k squared equals to 0. Right, so that is the quadratic equation. It's so complicated because we don't know what k is. Right. Eventually, we don't know what k is. We only know is that the discriminant will be greater than 0. When there are two intersection points, you can translate it into the idea it has a positive discriminant. Alright, with the discriminant greater than 0. That means 4k minus 14 square minus 4 times 5 times 12 minus 8k and k square is greater than 0. Alright, it's greater than 0. That would give you minus k square. After simplification, of course. Alright, once again, I suggest to try do it on your own. I might have made mistakes, like usual. Alright, so minus 11 is greater than 0. Alright, so this is a quadratic inequality. The roots are 1 and 11. The roots are 1 and 11. Alright, it's negative, so it opens downwards. This is negative, so it opens downwards. Alright, the roots are 1 and 11. You want the part that is greater than 0. greater than 0. So the answer is k is not x, right? It's k lies between 11 and 1. So this is the answer to this question. All right. So now there are 3 examples in this video. Try to revise all 3 examples. It's a very concise, it's a very summarized description of the intersection between circles and straight line. You may wish to refer to the book, the textbook, for more examples and exercise as well. Alright, so this is the end of part 4.